Question 7.81 is kind of an interesting question. It says when 1R2R2-bromocyclohexanol is treated with a strong base, an epoxide or a cyclic ether is formed. Suggest a mechanism for the formation of this epoxide. So if I'm treating this starting material with a strong base, the most acidic proton in this molecule is going to be the hydrogen atom that's attached to the oxygen. So here I could represent my strong base just like this. So if I draw a chair, of that cyclohexanol derivative, so if this hydroxyl group is going to be axial, so if it's going to be axial, I could draw it like this. That would mean that this bromide, since it has a dash, that would mean that it has to be axial as well, because if we go up and down, they're both going to be axial if they're on adjacent carbons. So that means that this bromine is going to be down like that. And you would remember that in order for an elimination to occur, so this is kind of a substitution, and when I say elimination, I really mean a loss of a leaving group. But if I treat this with a strong base, so you can see here, if I take my strong base and I deprotonate that, if I remove that proton, what I'm going to get is this intermediate where I have, now I've created a nucleophile and I have an electrophilic center here, both in the same molecule, because you know that this carbon here must be delta positive because it's attached to an electronegative element, which happens to be bromine in this case. So therefore, I can get kind of an SN2 process here. So I'm going to draw the curved arrows for that, where it's going to do a nucleophilic attack on this carbon, and I'm going to get my loss of leaving group like that. And if I draw my final product, you can even see that this new ring that's formed should kind of be, or not kind of, it should be on top of the molecule. Oops, let me fix that one. It should be on top of the molecule like this, okay? Which would be the same thing as writing, you know, my cyclohexane with my epoxide on it, like this, okay? And something our book doesn't talk about, but I think it's worth mentioning, is that if you look down this carbon-carbon bond, so if I highlight, let me just kind of highlight it here in black. So if you look down that carbon-carbon bond, okay, and I'm not going to draw the Newman projection right now, but you can see that if you look down that carbon-carbon bond, that this bond to the oxygen and this bond to this bromine, those are antiperiplanar to each other, and that's not a coincidence. Anyhow, I just thought it was kind of interesting, and yeah, it's an example of a problem where you create a nucleophile in a molecule and you also have an electrophilic center in that molecule, and this reaction is called an intramolecular reaction because it's essentially reacting with itself.